Okay, I just want to say one more thing about section 4.3. The types of problems that I've shown you so far, I showed you a couple like this, where you have to make sure y is by itself, and then you can use y equals mx plus b to identify m the slope and b the y-intercept. And we did a problem out as well where we found specifically the slope using 2 points. Just one extra comment on this type of problem. I don't think there's variations outside of what I discussed, but I do know with the choices that they give you, undefined as an option for slope. And I just want to let you know that the types of lines that I don't think are represented in this section but you should know about, and were in the previous section, are horizontal and vertical lines. Don't forget about those. We talked about how horizontal lines just have a y in the equation and not an x. Vertical lines will just have an x in the equation and not a y. So this thing doesn't qualify as either. This is going to be some type of diagonal line. But just remember that when you talk about something that's a horizontal line, horizontal lines have a slope of 0. So if you're ever asked to fill something in for a horizontal line, you'd say slope 0, and then the y-intercept would be wherever that line is crossing the y-axis. If the slope were an x equation or vertical, the slope would be undefined. So I think in the next section you'll have some examples like that, and you'll have to think about slope for those types of lines. So you'll want to know that the slope is undefined for that type of problem, and that the y-intercept, unless it's directly on the y-axis, there is no y-intercept for a vertical line. There's only an x-intercept. If it's actually on the axis, it would have infinitely many y-intercepts because it's the y-axis itself. But those are just some little technical points to think about, and we'll look at more of that stuff coming up.